Saxon Algebra 1, Lesson 19. In this lesson, we will learn about exponents, powers of negative numbers, roots, and evaluation of powers. Multiplication by a whole number is a shortcut for repeated addition. For example, if we want to add 117 to itself 5 times, it is easier to just multiply 117 by 5. Using x instead of 117, we can write x plus x 5 times is x times 5, which is the same as 5x. Now, what if we want to multiply 117 by itself 5 times? Is there a shortcut for this? The shortcut is to use an exponent of 5. 117 times itself 5 times is 117 to the 5th power. Using x instead of 117, we can write x times x 5 times is equal to x to the 5th power. So here's the definition of exponential notation. If you multiply x by itself n times, that is, if x is a factor n times, then you can write x to the nth power. Of course, this is true when n is a positive whole number. X is called the base, and n is called the exponent. The value of x to the nth power is called the nth power of x. Here are some examples. X to the 3rd power means x times x times x. 2 to the 3rd power means 2 times 2 times 2. And that happens to be 8. 2 times 2 is 4, times 2 is 8. 3 to the 2 power is equal to 3 times 3, and that happens to be 9. We also call that 3 squared. Negative 4 to the 2 power, or negative 4 squared, means negative 4 times negative 4, and that is positive 16. Remember, 2 negatives multiply to a positive. 1/3 to the 4th power means 1/3 times itself 4 times, and that happens to be 1 over 81. You multiply the numerators and the denominators. The word power is used to name the value of an exponential expression. For example, 2 to the 4th has the value 16. We also use the word power to name the exponent, and we usually say things like 2 to the 4th power. Certain powers have special names which come from geometry. If you want to find the area of a square whose sides are 7 units long, you would multiply 7 times 7. This is 7 to the 2nd power, which is usually read as 7 squared. Similarly, a 3rd power is often read as a cube. For example, 7 to the third power can be read as 7 cubed. This is because the volume of a cube can be found by multiplying the length of a side by itself 3 times. A cube is the three-dimensional version of a square where all sides are of the same length. Here's a picture of a cube. If each side is 7, then the volume of this cube is 7 times 7 times 7, which is 7 to the third power, or 7 cubed. We will learn more about volumes in the next lesson. Now let's look at powers of negative numbers. When a positive number is raised to some power, the result is always a positive number. But when a negative number is raised to some power, the sign of the result depends on whether the power is even or odd. For example, negative 4 squared is negative 4 times negative 4, and two negatives give us a positive, so that's positive 16. On the other hand, negative 4 to the third power is negative 4 times itself 3 times, and three negatives give us a negative, and the answer is negative 64. Negative 3 to the fourth power is negative 3 times itself 4 times, and an even number of negatives multiplied gives us a positive. So this is positive 81. If you do them in pairs, negative 3 times negative 3 is positive 9. That's the first pair and the last pair, and 9 times 9 is positive 81. Negative 2 to the fifth power means negative 2 times itself 5 times. An odd number of negatives multiplied give us a negative, and that happens to be negative 32. If the power is even, the result is positive, and if the power is odd, the result is negative. When finding a power of a negative number, it is very important to enclose that number in parentheses. For example, the fourth power of negative 3 must be written as parentheses negative 3 to the fourth power, and not as negative 3 to the fourth power without the parentheses. When the minus sign is not inside parentheses, it indicates the opposite of whatever follows. So negative 3 to the fourth power means the opposite of 3 to the fourth power, so that is negative 81. That is, parentheses negative 3 to the fourth power is positive 81, but negative 3 to the fourth power without the parentheses means the opposite of 3 to the fourth, which is the opposite of 81, or negative 81. You might try that on a calculator. If you don't put parentheses around the negative number, and you use negative 3 to the fourth power, you will end up with negative 81. But if you do enclose it in parentheses, you will end up with positive 81. Here are some examples. Simplify each of the following. Negative 5 in parentheses squared. Since it's in parentheses, it means negative 5 times negative 5. And that's positive 25. But what if we have negative 5 squared? There are no parentheses, so that means the opposite of 5 times 5, the opposite of 5 squared, and so that's negative 25. Negative 2 in parentheses to the third power, or negative 2 cubed, means negative 2 times itself 3 times. And that is 4 times negative 2, and so that's negative 8. Negative 2 to the third power, without the parentheses, means the opposite of 2 times 2 times 2. In other words, the opposite of 2 to the third power. And so that's the opposite of 4 times 2, which is negative 8. Negative 3 to the third power minus parentheses negative 3 squared plus parentheses negative 2 squared. We have 3 powers to deal with here. The first is the opposite of 3 to the third power. Then we have subtraction minus negative 3 times negative 3, and addition plus negative 2 times negative 2. So if we look at each of these terms, we have negative 27 for the first term, minus positive 9 for the second term, plus positive 4 for the third. And that gives you negative 32. Here's another one similar to the last problem. Opposite of 2 squared minus 4 times negative 3 squared minus 2 times negative 2 squared minus 2. We have to be careful about each term. The first term means the opposite of 2 times 2, the opposite of 2 squared. The second term, we're adding negative 4 times negative 3 to the third power. The third term, we're adding negative 2 times negative 2 to the second power. And the last term, we're adding negative 2. Now if we do each term, we have negative 4 plus positive 108 plus negative 8 plus negative 2. And that gives us 94. Now we will discuss roots. Suppose we have a square with an area of 36 square inches. How long is each side of that square? Each side of a square has the same length, so we need to find the number whose square gives 36. What times what is 36? This number is called the square root of 36, and we use that square root symbol to represent it. Since 6 squared is 36, the square root of 36 is 6. A square root is what we call the inverse of a square. Inverse is sort of like opposite, but in algebra we use the word opposite exclusively for signed numbers, like the opposite of negative 3 is positive 3. So, for example, if we know the square of a certain number is 289, then that number is the square root of 289. In other words, if x squared equals 289, then x is the square root of 289. Since 17 times 17 is 289, the square root of 289 is 17. The square root symbol is called a radical sign and tells us to find a number whose square is the value inside. Now suppose we consider negative numbers. It happens to be true that negative 17 times negative 17 is also 289. So negative 17 squared is 289. Therefore, negative 17 is another square root of 289. That is, if x squared is 289, then x could be 17, or it could be negative 17. Because of this kind of confusion, we use the square root symbol to indicate the positive square root only. And if we want the negative square root, we have to place a minus sign in front. The square root of 289, therefore, is positive 17, and minus the square root of 289 is negative 17. On the other hand, if we try to take the square root of a negative number, we run into trouble. For example, what is the square root of negative 25? What number times itself is negative 25? The answer can't be negative 5, because negative 5 times negative 5 is positive 25. In other words, negative 5 squared is positive 25. And it certainly isn't positive 5. Therefore, square roots of negative numbers are not the real numbers we know about. When you get to Algebra 2, you will study what's called imaginary numbers. Then we can deal with problems like this. If you ever see a problem like square root of negative 25, then you should answer not a real number. Negative the square root of 25 is negative 5, but the square root of negative 25 is not a real number. Do you see the difference? If the minus sign is inside the square root, we have a problem. Now it happens that there are other kinds of roots besides square roots. There are cube roots, fourth roots, and so forth. For example, if you want to find a number whose cube is 343, that is, the number times itself 3 times is 343, then you can use the notation square root with a little 3 in there to represent it. This is called the cube root of 343. We don't read it as a square root, we read it as a cube root. If x third is 343, then x is the third root of 343. That is, if x cubed is 343, then x is the cube root of 343. The little 3 in the radical sign is called the index of the radical and tells us we are trying to find a number which multiplies by itself 3 times to give 343. The nth root of a number is another number whose nth power is the original number. It's written like this. That's the nth root of x. The nth root of x equals a number a, means that a to the nth power is equal to x. When there's no index in the radical sign, it means square root. So if we write it this way, square root of x equals a, that means a to the second power equals x. When the number x, whose root is to be found, is positive, then the answer, or the value of the root, is positive. If the number x is negative, then the answer is negative only if the index is odd. and the answer is not a real number if the index is even. Here are some examples. See if you can give the right answer before it is shown. Cube root of -8. That's -2 because -2 times itself 3 times is -8. Fourth root of -8. That's not a real number, because a negative number times itself 4 times would be a positive number. The 4 is even. Fourth root of 81. That's 3. Because 3 times itself 4 times is 81. 3 times 3 is 9, and another 3 times 3 is 9, and 9 times 9 is 81. What's this? It's -3. That negative out front means the negative number whose fourth power is 81. -3 times itself 4 times is 81. That's the square root of 81. It's 9. 9 times 9 is 81. What's this? Fifth root of -32. It's -2 because -2 times itself 5 times is -32. Evaluation of powers. Evaluation of expressions with exponents is easy when everything is positive. For example, if y is 3, x is 4, and m is 2, then the expression yx squared m to the third power simply means 3 times 4 squared times 2 to the third power. You evaluate each of those powers, you get 3 times 16 times 8, and that multiplies to 384. Notice that you have to evaluate the powers first. Then you do the multiplication. We must be careful, however, when the expressions contain minus signs or when some replacement values of the variables are negative numbers. Here are some examples. If a is -2, what is the value of each of the following? The first one is -2 to the second power, -2 squared. And that's -2 times -2, which gives us +4. The second is the opposite of -2 squared, and that's the opposite of -2 times -2, so it's -4. The third is the opposite of -2 to the third power, and that's the opposite of -2 times -2 times -2. Count the negatives there. It's the opposite of -8, which is +8. The fourth means the opposite of a times itself 3 times. And if a is negative 2, the opposite of a is positive 2. So we actually have positive 2 times itself 3 times, which gives us positive 8. Second example, evaluate x squared z cubed to y. If x is 2, z is 3, and y is negative 2. Substitute the values there and do the powers first, and that gives you negative 216. Third example, evaluate pm squared minus z third. If p is 1, m is negative 4, and z is negative 2. Put those values in the expression. Evaluate the powers first, the negative 4 squared and the negative 2 to the third. And we end up with 16 plus 8, which is 24. This is the end of Lesson 19. Your assignment, problem set 19 on pages 85 and 86 of your book.